Hey, everybody. Thank you very much for hanging out with us today and swinging by and checking out Todd-versations. I am beyond thrilled for this episode that we've got going on today. I have been pursuing this guy for a while to get him to come on and share with us about what he's about and what they're doing. As you can see behind me, we're talking to our friend from NASA today, which should be a kick. He's a pioneer. He's a farmer. He's a visionary. He's been around NASA for 30 years. He probably knows where the aliens are. He's a senior project manager for spacecraft production in support of deep space exploration. Get that, kids. Get that, kids. That's what we're talking about today. Please welcome Ralph Fritsche from NASA. Ralph, welcome.
Thank you, Todd. Appreciate it. Glad to be here. I hope I can live up to that wonderful introduction.
Well, I hope at the end of this you still like me. That's my goal in all this every time I start off on these. So far I'm doing pretty good. I'm about 50 for 50 right now. So I want to keep it going.
No worries on that count.
I really appreciate you being here as you sit on the space coast of Florida today, enjoying, I'm sure, beautiful winter sunshine. But before we get going, I'd just like for everybody to kind of get to know you real quick, if you wouldn't mind. Just give us a brief little bio and a little journey as to how I roped you into sitting here today.
Wow. So I forget how you actually found me. I tried to hide. But let's see, my story goes back. I've been working on the space program in some capacity since 1982. I was originally a contractor at the Kennedy Space Center, then switched over to NASA in 1989. But interestingly, most of my career had absolutely nothing to do with biology. I was working on space shuttle payloads. The first mission I supported, I think, was STS-5, and then worked after a period of time with Challenger, moved into International Space Station assembly. We were starting to, go ahead and building the plans for the space station. Switched over to that program, still in my same organization, and it was basically space station assembly for all the U.S. Modules, as well as the European ones, the GEM Japanese module, Columbus European module. They were all processed through the Kennedy Space Center, and I worked in operations in that regard. Once space station was done, then our organization needed to transition our role somewhat, and so we moved into sustaining and utilization, primarily utilization. So all the experiments that went up into the space station, a bulk of those for the US based experiments would get processed through, if they were going up on the space shuttle or now going up on SpaceX, through Kennedy. Right. And so we were doing biology payloads. My role was still in a project management function. Again, didn't really get into the specific biology and science of things. And this is about 10 years ago now. And then we came up with a project, at least one of our funding sources did, that was food production. And no one really knew what that meant at the time, but we had a couple of, really one payload at the time, the Veggie Payload, that was able to grow plants in space. And we knew it would have something to do with that. At the time, we were thinking about, can I get some of these plants that I fundamentally grow for research, basic primary fundamental science? Is there possible to grow some things that are not really model organisms that wouldn't be consumed, but can I grow plants that astronauts would eat? So folks in my group started working that, the science people, trying to get the approvals. Finally, we got approval for astronauts to eat some of the lettuce that we grew. And then it took off for there. Food production then became a topic that got a lot of publicity. The veggie experiment resonates with people because they get to see things that they're used to and familiar with growing in space, and they see something that's kind of looks out of place in the spaceflight environment. And so that's really just, it's taken off from there. As we start thinking for exploration now, we start looking at a food system, and we're going to have to sustain and supplement that prepackaged food that we've relied on since the beginning of the space program with things that we grow, because we're just going on missions that are going to be further away, that are going to take longer than some of these prepackaged food items will last. We want to focus on Earth independence. We can't have this long tether consistently going back to the Earth, so we're going to have to think of ways to become self-sufficient and live off the land. And so the project that I'm working with now, I really am at the strategic end of trying to see where does it make sense in our exploration roadmap and timeline to talk about adding fundamental, systems that are going to be supplemental for nutrition. And plants are really the main role to do that now, because they're the easiest to grow. We can talk about exotic food items, but really most of those are even being right now developed on Earth use a lot of infrastructure, volume, mass, power, water. We don't have access to that. Plants seem to be the most basic component that we could actually consider growing at the beginning. So that's really going to be the foundation for us. And that's why crop research is part of the food production aspect, and the food system is what we're all about now. So I come in with virtually no background in that arena, but fortunately I work with some really smart plant scientists who've been at it for a long time, who've been groundbreaking back since this early 80s working in this arena. And so I can rely on them for all the technical things. I let them do the down and in type of work, and I kind of work with different funding sources and organizations to lay out the larger roadmaps that'll eventually let us, get these systems on missions to Mars, on the surface of Moon and Mars.
I love it. I love it. Thank you for sharing that. And that's why I'm excited about the show. I think it's going to be a really cool conversation. So I want to frame up for everybody a little bit, just to give a point of reference. One of the big things that's out there today is CEA, or controlled environment agriculture. And it's all the rage. It's everywhere. I mean, it's in Time Magazine, to Wall Street Journal, to your local, they're popping up almost in every street corner in a lot of ways. But I want folks to kind of get an understanding of where that actually came from. And NASA actually initially pioneered some of these techniques on really built the country's first vertical farm inside an old hyperbaric chamber that was left over from the Mercury space program. And it's like, I don't think people recognize that, it was you all that were trying to put 2 + 2 together that has now almost created this massive new movement that's out there in the food space. And food, as we talk about this and getting into space a little bit, which is what we're going to cover in some of the questions I have for you, food has always been a pivotal part, I think, of exploration, from, hunting the plains of this country as this country was developed, to recognizing that they needed to put citrus, to prevent scurvy on the open seas long time ago. And some of the issues that you guys face, and you touched on a little bit, when it comes to growing food up in space, is water, power, crew time, equipment, launch, mass, weight, all these different variables come into play. And I think space exploration and living on other planets ultimately will require a food system. Of course, I think it's going to be less dependent upon Earth, and which I think we'll touch on today. But, I think about this and trying to prepare for this, that, feeding astronauts for a long period of time in space means figuring out how to stretch resources and, how to grow plants, how to minimize water. You don't have a tractor up there, and you certainly don't have any soil. And given where we're trying to go from a planet standpoint, I'm pretty sure you're not going to grow much out there. At least we haven't found a place quite yet to be able to pull that off. So I wanted to kind of frame that up for everybody to get them thinking a little bit about this process, because in some ways this is like the wild, wild west. You guys are forging technology and ideas and moving the ball down the field for something that is, almost out of reach in some ways as you're pulling that reach closer and closer. So to me, it's a really, really exciting subject to talk about. And I'm thrilled that you're here once again. And I do appreciate you taking your time out of your busy day to kind of hang out with us. So with that being said, and framing up a little bit of the CA backdrop, I think it's great that people kind of put that in the back of their mind when they think about what you guys are trying to do. So the first question I want to throw at you is, can you kind of just give everybody the third grade thought process, the 411, a little bit about what food was like back in the Mercury missions? And for those that don't have dates, Mercury was the late 50s through the mid 60s, I think is kind of that time frame ballpark. And then now what we're dealing with up on the International Space Station, which, by the way, folks, if you don't realize this, you can go online to NASA, you could plug in your location and it'll tell you when the space station is going to fly over top of your head. And if you never stood outside in the early morning, dark sky or late evening sky and seen the space station fly over you, it's pretty damn cool to see. So it is something that everybody can go do. And you should go take your kids out to do it, because it'll blow them away to be able to see something like that floating over top of your head. It's pretty cool. So what was the food like compared to Mercury to today?
Hi, I'm Nate Hefty, Vice President of Sales at Superior Fresh, the nation's largest aquaponic farm located in central Wisconsin. Thank you for listening to Todd-versations and Todd Bits. Check us out at www.superiorfresh.com to learn how we raise our Atlantic salmon on a non-GMO organic diet. And they thrive in water naturally filtered by our USDA certified organic leafy greens, never treated with hormones, antibiotics, or pesticides, and packed with 2 times the omega-3s. This is salmon as it should be. Shop with us online and use the discount code TLC 2022 to receive free shipping on all of our American Heart Association's Heart Health Checked Atlantic salmon. At Superior Fresh, we are changing how food is grown to change the world. Remember the code TLC 2022 to get free shipping.
So, initially when I think the first astronaut to consume anything in spaceflight on the U.S. side was John Glenn, and they weren't even sure if you'd be able to swallow, drink, or consume things. So I think they had some sugar tablets. They had some, I think it was applesauce in a tube, and some water. And I think actually it's interesting that the tube that he ate out of is still somewhere in the Smithsonian Museum. In file someplace. I wouldn't want to eat it now. So that kind of illustrated that, yeah, you can consume things. We, on the U.S. side, we demonstrated that. And then everything became these freeze-dried, you had to reconstitute it type of packages. And so that really set the mindset in that when it came to food, this was something you were shipping from the earth. And so I think of it, some of the, I think, struggles we deal with now is this mindset change. Since the beginning of the space program, food was always a logistics quantity. It was something that you shipped up from the ground. You didn't need to have infrastructure to grow or even necessarily process and prepare. Like right now, even on the International Space Station, we don't have a refrigerator, we don't have an oven. Right. So we reconstitute things with a warming plate or with water. A lot of it is thermostabilized. It's very quality food. I mean, the folks at Johnson Space Center who developed the prepackaged food do an outstanding job of making things that are healthy, nutritious, and palatable for crew. And they tailor things for different astronauts where they can, depending on the composition of the crew. But, it was an incremental thing. And again, the big thing is that it was always something that it was a logistical item. When I start talking about exploration, now all of a sudden I'm talking about, well, now I'm going to have to, to lack of a better term, manufacture some of my food. And right. In this case, we're talking about plants and growing them, but that requires infrastructure. And when you're talking about vehicles that are very limited on power, volume, mass, now you're having a new player come into the room, and he wants a piece of that. And now everyone else is going to have to, make allowance for that. So it's a sell, because everything we do with growing plants, it has an impact, for example, on the environmental control and life support system. How do these systems that process human respiration now have to take into account, or do they, the plants that transpire, the water? So, we're kind of, we affect other systems, and that becomes part of a challenge in working and getting approval for the things we do. But yeah, it's evolved over time. I think that if you look at the history of the space program, and I'm not, even though I was around that, I'm not necessarily an expert at it. I think Skylab missions had probably something more akin to an exploration, galley, where you would think of if you were talking about polar or Antarctic explorations, where you had crews being able to prepare meals, sit down at a common table, and consume things. Right. That was probably the first place. I think they had more infrastructure than any other time before or since for meals. And then you get into the space station world, and now we have a very high quality food system with a lot of variety, relatively speaking. You have over a couple of hundred items that can be brought up, but it's still a cyclical meal that I think it's like every 8 days the meal system repeats itself for whatever they have stored that period of time. So, right. So I'm not an expert totally in this area, but you get the feeling that right now we're making do. And even today, what you see as an issue is that most astronauts come back and they lose weight. And generally speaking, while they've been flying, they've lost weight because either their tastes change, they get menu fatigue. There's a whole list of factors that cause them not to eat everything that necessarily is provided. So food, nutrition, astronauts, and performance, and how we keep them healthy and operating at that peak performance level is a real challenge. And it's one of the main topics that the Human Research Program of NASA, again, basically housed out of Johnson Space Center, deals with. Right. So what we do with crops is really we support those food system folks at Johnson because Kennedy has the charter to be the lead center for plant and crop research. So we work right. very closely hand in hand with those folks at JSC going forward with how can plants supplement this prepackaged food system, which again, over time, and as we get further from Earth and we talk about missions that are maybe resulting in permanent or semi-permanent outposts on the moon or Mars, we're going to have to figure out how do I, decrease the amount of logistical resupply. And that's going to be done by growing things in situ. And that, is going to start off at plants, but eventually it'll expand to other things, the kind of things that we're even dealing with terrestrially here today. You spoke about CEA. From our perspective and my exposure to everything, NASA's work in space plant production and crop production is very closely linked to the CEA work that's being done today.
Right.
We go to and support lots of conferences. I've gone to a lot of vertical farming facilities. You mentioned the first vertical farm that was done over in Hangar L, I believe, on the Cape side. And Dr. Ray Wheeler was instrumental in that. He works in my group today. So we get to share a lot of this information. Having Ray around is like having a HAL 2000 computer at your disposal for anything plants. If we have a question, you just go into Ray and he shares his information. The interesting thing is that we have so few people working in this field, though, that I have people who are doing all this down and in specific crop research, looking at different challenges with growing plants in a microgravity environment. And then you have me who's out there trying to steer the ship down the road saying, where is our next opportunity? So it's an interesting thing. I think the food system has really evolved over time and will continue to evolve over time. I think for the longer duration missions, what is going to happen that maybe hasn't been so pronounced as it was in the past is that just because of the duration of these missions, there is going to be a psychological and a psychosocial benefit to having fresh produce, good food there, because it's going to be one of the few things that crews, when they're away from Earth for longer periods of time, it's going to remind them from home. It's going to give them, this comfort level and benefit that they didn't necessarily have to rely on in the past when missions were shorter. So
Right.
I could go on forever. So
No. Can you just real quick, because you touched on it, and I know it's something I wanted to bring out. Can you talk and just explain what in situ means to everybody so they're kind of get hip to that, the ISRU?
Yeah, so we talk about ISRU, in situ resource utilization, and that's basically trying to figure out how do you live off the land. If I talk about crop production, one of the key things is you're going to be looking from other systems. You're going to be looking for example, on Mars, how do I extract water? We read just recently about waters being found in the canals on Mars. We know we're going to need water for a variety of other factors. So it's things like water. How do I generate oxygen as part of this process? Plants can play a role in that too. If I have enough plants going, I can produce enough oxygen, process enough CO2 so that I'm revitalizing the atmosphere. When I talk about ISRU, it could also mean things like resource utilization of regolith. How can I take the in situ material that's on the surface of the moon and potentially convert that into a substrate that's usable as a soil would be on Earth for plants? Right. So there's a multi-step process in there. I'm not saying that's the way we would go. While we're looking into that, I go into it interested and excited about it, but somewhat skeptical, just because there's a lot of issues associated with bringing this material into a controlled environment, dust. How do I convert it? Is it going to require more energy and more expense to convert this material into a usable soil than it would be to do a hydroponic or an aeroponic system? Right. When I look at controlled environment agriculture, I see hydroponic and aeroponic systems. I don't see them bringing in a lot of material and growing in a substrate. But depending on the plants, depending on the crops, the scale, who knows? So we're looking at that just at a very early way, trying to see, are there trades there? Is there a use case where it makes sense for one versus the other? There's advocates on both sides, but I think right now with our experience on the International Space Station, we're looking more or less, hydroponically in whatever derivative of that it may be, especially when I'm talking about these longer duration missions to Mars, to and from Mars, where I'm just transiting there, I'm doing something on the surface and I'm coming back. We're not going to be flying soil and substrate. We simply don't have the mass allowance to be able to do that. And even now, what we do on ISS with Veggie and Advanced Plant Habitat, those systems have a substrate. It's a media that's like a baked clay. It's called arsenite.
Mhm.
But they're single use, and then they're done, and you have to get rid of them. So there's this weight penalty that's just, and it's not a sustainable system. So when we talk about ISRU, we're talking, at a high level about living off the land and being sustainable.
Right. Thank you for
sharing.
Yeah, no, thank you for sharing. I think it's important that people recognize the depth of how you all are thinking about how this is going to work. Because flying to Mars isn't like driving, couple 2-3 hours. It's going to take a few days to get there. And so, to your point, a few days. What is it? What is it? What are they saying? Is it 3 years? Is that the number?
I think that's what we talk about, and it depends on the power source for the engines that are going to get us there. So there's some slop in that, but we kind of think in terms of 3 years.
Well, you go 33 months to 36 months. Who's going to split hair? It's still 30 months, right? One of the things you touched on, and I just want to come back to it really quick. Because of the space station up there now, and the fact that we're creating this super highway of space Ubers, it seems like, with the folks that are putting out engines and flying up there and resupplying and stuff. It certainly has to make, to your point, a better food experience for everybody, because they are getting food brought up a little bit more regularly. And I'm assuming now they probably get some fresh options like, apples and things like that have minimal waste, minimum weight, et cetera.
Yeah, so let me talk about that a little bit, because there's a big shift in what's going to be happening when we start going out for exploration. Right now, there's basically, lack of a better term, 3 aspects or components of the food system. One is the prepackaged food I alluded to. Right. Then there's the fresh fruits and vegetables that they'll get at resupply, which have a limited shelf life for them. And then there's also crew preference items. So depending on who the crew member is, they can fill out something in advance as, hey, I like Chips Ahoy cookies, some other thing, whatever it is. And they'll package those up there just, for a preference item. When I start talking about a trip to Mars, it's not been determined yet as to how we're going to approach it, but there's not going to be any resupply. So the fresh fruit and vegetables, if you don't grow them on board, they're going to be gone before you know it. Right. And then crew preference items, it's very possible that depending on the nature of the missions, if we have to pre-position food before the crew gets there, that you may not even know who the crew is before that food has to be sent. So crew preference items, likely minimal to none. And so that leaves you with the prepackaged food that we've traditionally relied on, or what we can grow. That's a big change. And I think even before we talk about this long duration trip to Mars, you're going to see the early missions to the moon. They're going to be short enough in duration that, it's going to be pretty much the same food system we have now for the microgravity experience. But when I get to the surface of the moon, time is going to be of the essence. The amount of time and the amount of mass we can take to the lunar surface is such that the food that the crew consumes on the moon is going to be highly restricted to compare to what we see now on space station.
Yeah, well, and I think it's great. We kind of framed this up at the beginning. I'm just going to reiterate it. Is that you all are working with a very fine lane of swimming in to be able to go up to space. We're talking about the fact ounces matter when you guys are doing the math. You guys look at every possibility of what this is. What are we taking up? What is the waste we have because of it, et cetera? I mean, it's a giant puzzle. The business that you're in, it really is.
Yeah, and some of it's not even in our own. It's not in our control. Like, one of the things that will be a challenge for us is we're going to have to see how other systems required for the mission to Mars come out and design and perform before they'll even know if they can afford to put a crop system on board. Right. And if they can't, then that's a risk that has to be taken, into account for the first missions to Mars. It's not something I would want to have to proceed with. And I know that the key players in the agency don't want to have to go that way, but, we'll have to see how it plays out.
That's amazing. It's just amazing. One of the things that you guys are involved in, and I want to touch on this before I get kind of deeper into some of these other questions, is the Deep Space Food Challenge, because I think it kind of helps frame up the CA conversation where we are at this point. How is that competition helping solve issues surrounding microgravity growing in space and long-term crop production? And what are some of the exciting outcomes that you're seeing or hoping to see from it?
So I think when it was originally envisioned, it came about because our folks at Johnson went off and kind of canvassed the spectrum of potential food production concepts that were being developed terrestrially and tried to see if there were any of those we could bring forward that were mature enough to bring forward into spaceflight. And the survey just basically said that there weren't any. At this point, everything was too immature to even consider being ready to put on a space mission. So this was a chance to make sure we hadn't missed anything, to make sure that there wasn't something out there that we were not aware of, let folks come forward, and then also to be able to give people an incentive to, consider developing something in this space. There's a lot of people either in the CEA community, engineering, who just love space and they wanted to see if, hey, could I come up with a solution? It wasn't meant to be necessarily a crop solution because we think we have a pretty good handle on a lot of that. It was looking for novel ideas. And so when the submissions came in, they were kind of all across the board. And there was nothing that I could say you could, take this idea and start manufacturing it and building it, incorporating it tomorrow. But there are aspects of individual systems that, given some time and development, have the potential to become players in this space. So I think that's where we're at now. We've completed successfully phase 1 of the food challenge. We've had 18 winners selected from that. We've just completed developing the rules for phase 2, and that's going to go out so that the people who participated in phase 1, and I believe even people who haven't, can go ahead and look in phase 2 and say if they want to continue on. Phase 1 was very much a conceptual approach to things, nothing in terms of hardware. They didn't have to prove or build anything. This one is coming up, phase 2, is going to be basically a tabletop demonstration of at least some aspect of their production approach and methodology. And it's going to focus a lot more heavily on food safety in terms of the product that they develop, as well as food safety in terms of the cleanup and making sure that these systems are reusable and safe over time. So each step in the challenge, there may be a third part of it, gets a little bit more technical, a little bit more realistic. And the hope is that we'll be able to at least, take aspects of some of these different systems and incorporate them in some type of future system.
Right. Oh, I love it. And it's so cool to see these young guns, these young companies with these these great ideas coming to fruition and having the support and a place to go to expand those ideas. Because, one of the things you just said, which was use the word food safety. And I'm excited about the opportunities that who knows what the future will hold when it comes to food safety. I mean, it's a big issue for this entire planet. It's certainly a big issue constantly in the news, whatever it might be. So that to me is really exciting to think we've got, all these big brains getting together to kind of work on a common goal, and the outcomes no different than thinking about CEA, back when you guys had basically the container for mercury out there playing around trying to figure out how to make it work. I mean, I love how we chart this path. I mean, that's the neat part about space exploration in my mind. It's all the other things we're exploring to get there are going to end up making this a better place. And I think that's really cool. One of the things that you guys work with are bioregenerative food systems. And I want to touch on that because I think it's a great thing for people to understand. And I want to kind of bring it back to what's out today, similar to CEA we touched on earlier, about regenerative agriculture, right? It's not the same thing. Regenerative ag is a rehabilitation approach to the soil, the topsoil, increasing biodiversity, et cetera. But bioregenerative life is a little bit different support system. Can you touch on that a little bit for everybody?
Yeah, I think, Dr. Ray Wheeler, again, who I work with, is always being a big proponent of bioregenerative life support systems. I think I've learned whatever little I know from him. And you've seen different countries invest in trying to develop a controlled life support system at a small scale, a bioregenerative system. And it seems to be extremely challenging to do. If I look at Biosphere 2 out in Arizona, that was a grand scale approach and that had a lot of challenges. It's not easy. So that's just doing it terrestrially. So I think, though, that the future, when I talk about sustained, permanent, semi-permanent outposts on the moon and Mars, we're going to get to the point that that's what we're going to need. And I was just asked this earlier today, how do I see this, taking place? And you've got different components of any bioregenerative system. Plants can enter into it because they provide a source of food. They can do atmospheric revitalization in the conversion of CO2 to oxygen. They can also do water purification. So they're a good player in that regard, but it's going to be a symbiotic relationship with other systems that it's going to go, hand to hand. And so we're just working on one aspect of it. I think that a real bioregenerative system, I think a lot of universities have looked at that. They've come up with concepts. These things are larger scale systems that require a lot more infrastructure, that are going to move them out on that expiration timeline beyond the window of time that I can really even begin to plan for. I think that the best we can do is lay the components that we can be responsible for, so that in the future, when they talk about how do I set a system like this up, we've got a mature series of plant growth operations, hardware to be able to be a player in that and make it successful.
Right.
But again, I think it's really challenging. I haven't seen anybody do it easily.
Yeah. I want to get into a little bit about the plants and growing plants and just kind of that thought process up, because it's you're not doing it in your kitchen window, kids. This is a lot to this. And one of the areas that I know that we talked about earlier is about payload, what you can bring up, right? So you can't haul 5,000 gallons of water on a space, on the way up just to water plants. There's got to be a way of doing it, and you've got to come up with fertilizer. You got to go saying. So I'm going to throw a big random question, let you run with it any way you want, because I know this isn't necessarily your bailiwick, but a little bit about water and how that works up there, as well as human waste and creating compost and creating that kind of environment. I'm going to throw it all together and just let you run with those two kind of concepts about how you're going to try to, create a plant up there.
So you talked about it in such a way that almost still has aspects of bioregenerative, in that, one of the things we're trying to do in that regard is to close the mass loop. So that pretty much means that there's no waste that you just dispose of. There's only something that you recycle and repurpose.
Right.
And that's really important for any system we bring forward. If we're going to recommend a system for a future mission, the more it can, repurpose the mass, less waste, the better. So if I have a plant growth system that can take gray water and clean that up and put it back into its own system, that becomes, a positive thing. If I can give off more O2 to the crew, that becomes a positive thing. So we're really looking at trying to, tighten up that waste stream to be able to pull out as much of it as possible. Even if it's nutrients that I feed the plants, when I get to the waste stream, I want to pull out as much of that material as I can and reintroduce it into the nutrient stream. So we're all about trying to close that mass loop. And that's the way what a bioregenerative system is that it's a closed mass system that you just add energy to, I think, at a very high level. I mean, I'm sure there's people who say there's a lot more to it than that, but ultimately you're trying to close that mass loop and the best way possible. So that's what we're trying to do with any of the systems we come up with for growing plants. It's a matter of how do I do that with minimal water. We have two plant systems on the International Space Station now. One is the Veggie Payload. We have two of those, and the other is the Advanced Plant Habitat. And to give you an idea, Veggie is a very simple system. It's basically just a light cap with fans that has a volume of space that as the plants grow, we can adjust this platform to lower it so that the plant canopy is roughly the same height from the light source all the time.
Right.
But it's an open system to the cabin environment. And so astronauts have to regularly water the plants in there, because that transpired water is going off into the crew compartment area, and then the environmental control and life support system handles that water just like it would, crew transpiration. So it's light, it's compact. The onus from a water perspective is now astronauts have to deliver more water to it, and the environmental control and life support system has to process the transpired water. Advanced plant habitat, on the other hand, has roughly the same growth area or growth volume that Veggie does, but it takes up about 4 times the space of Veggie on the International Space Station. And that's because it's a closed system that's responsible for basically recirculating and recovering all that transpired water and doing everything to get it back into the growth environment. As a result, though, you basically fill up the water tank in Veggie, and then it's only periodic top off. So there's a lot less in the way of crew time in that regard. And it's one of the open trades we have out there that's we're probably not going to get to until the next few years is, when we go forward with a system for a Mars transit vehicle, let's say, which way do we want to go? An open system, which will require more crew time for watering and impact on other systems, or do we want to do a closed system, which will require more mass, power, volume, complexity, potential for failures, et cetera? So, that hasn't been resolved yet, but that's all something we have to, look at and address. And, reliability is a big thing. Sustainability, reliability, crew time, all these
factors. There's unlimited amount of factors. Yeah.
I look at mass, power, volume, and crew time as all being limiting factors of resources that we have to be able to minimize our use of.
Well, it goes back to what I said earlier. It's really, you guys are really trying to figure out a puzzle. How do you get from point A to point B and the most effective manner?
Yeah, and there's very much the potential for different pieces fitting with other different pieces depending on where we're going and what the mission scenario is. A system for the surface of the moon is not going to be the system we take with us when I make my trips to Mars and back. There's so much going on. There's options, and there's going to be a lot of trades and down selects depending on what the mission profile is we're going to be looking to deploy these systems for.
Yeah, no doubt. That is so cool. So let's talk a little bit about engineering, plants for space, if we can, a little bit. And can you elaborate on this? Because there's a lot of factors involved with that. I'm going to kind of throw out a broad question again and just let you run with it. But, trying to engineer plants for space, you've got things like, cosmic radiation, galactic cosmic radiation. You got stuff up there that's going to affect things that in some ways we don't actually know the answer to that at this point in some aspects. What is 3 years going to be like? And what are happening with like seeds? If you take seeds up there, is that going to have any kind of effect? So it's a big, broad question. First talk about engineering plants. How do we deal with it? How does radiation and germination and all that kind of play into all this up in space? If you wouldn't mind, just kind of run, brother, run.
Yeah, sure. I'm even going to go back to the very beginning when I got involved in this this whole project. Is that you had a lot of plant scientists who knew the biology and knew plants, at least, especially from a terrestrial perspective, very well. And you had a lot of engineers who knew how to design flight hardware, but they knew nothing about plants. So you had these two groups of people that had to, at some point, come together and learn enough about what the other's expertise was to be able to make a system that was somewhat reliable and, achieve the results we needed. I even have this quick story. There was one of our very first research payloads that I worked with that was biological, was such that it had to germinate seeds. The seeds were put in a very small little volume of containers, and they were going to be exposed to a magnetic field. And we couldn't get the seeds to germinate. And so, as is traditional, because this was all an engineering thing and was part of our space station team, we had to bring it to our chief engineer in the payload world at Kennedy. And he went through the checklist and the fault tree and went through everything and saw that we did everything right. He goes, well, these seeds have to germinate because the technical science, the engineering side of it would have said, you've done everything, they have to work. But biology doesn't play by engineering's rules. And so, this was a learning experience for the engineers as well as it was for, pretty much everybody on the team.
Sure.
We finally sorted it out. But yeah, so that's the big thing, is that you have to have these two parties working together. The engineering side has to know enough of the basic premise and principles of plant biology to have an appreciation for it. And the plant folks have to understand what the constraints are and the ability for the engineers to come up with solutions to meet them. When you talk about now, you mentioned cosmic rays and some of the things that we don't know about. And I think that's really connected to now getting beyond low Earth orbit. We've got, decent experience growing things in the International Space Station in low Earth orbit. We don't get exposed to the radiation environment there, the same radiation environment. There's discussions about how you could mimic it by extending the duration of your exposure. But realistically, you want to test things as you fly, and that's a good engineering principle, and it works for biology in this case as well. So we really need to bring, as you said, seeds at first up into this, new environment beyond low Earth orbit where only a few people have been, and we've never really tried to grow plants before. And even there's an issue. We're so used to the relatively short mission durations that we're going to actually be flying some seeds on the Artemis 1 mission that's going to go around the moon and back, and we'll get to see some of the exposure. We've also flown seeds on high altitude research balloons down in the Antarctic that have given us several months of exposure. We have seen, my understanding is, some morphological changes in terms of radiation exposure. We've seen some reduced germination for the seeds that were flown. So there's an expectation that maybe you'll have to fly more seeds. The morphological changes could be simply as much as you don't eat that part of a plant if it doesn't, fit the normal criteria. But then there's the fact that when I talk about a mission to Mars, like we said, it's a 3-year mission. Now, we've done nothing to verify what the exposure of the certain seeds that we're going to be, looking for astronauts to consume at those periods of time in that environment would be. It does me no good if I put seeds on the moon or take them up to, cislunar space on Gateway and leave them there for a year and a half, and everything is great and copacetic, just to find out that on the return mission from Mars, after 2.5 years, nothing grows. So we really need to make equivalent research studies with these things. And so getting the time and the recognition that, these are challenges or something we're going to have to do. And that's why it's also important that we consider deploying plant payloads, not necessarily for crew consumption, but just for fundamental research to see how they go. And we have to take advantage of any opportunity we have. So it's not just for crewed missions. We're actually looking at submitting a proposal for through the commercial lunar lander providing service for a payload that will go to the moon, somewhere in the south pole of the moon, where we're looking for astronauts to grow and actually see if we can grow some plants down there in this facility, just to see and get data back. Now, here's a case where there's actually, in my mind, there's some linkage even to CEA back on Earth, because these type of missions are not going to have human interaction. So the data we get back is going to have to be all telerobotic. Foundational to that, we're looking at advanced imaging systems like multispectral or hyperspectral imaging systems that can give us an indication of plant stress, plant health. These are the same type of systems that we're working with the USDA to develop, so that eventually they can be deployed in CEA settings. But even with CEA, we're taking I'd say a lesson on a page from their book, because they're focusing now not just on technology. They're looking at, as you said, also about engineering crops. They're looking, GMO has a connotation. So a lot of these folks are looking at selective plant breeding. They'll go to breeders, give them their, requirements for what they're looking for, what conditions these seeds have to perform well in, and they'll use AI principles and big databases to say, okay, we'll come up with this seed or that seed, or we can, relatively quickly, breed a seed that will meet your requirements. And so we're looking at doing the exact same thing, because it's as much as developing technology to ensure that the plants perform to their best as it is coming up with plants that are going to perform the best they can based on the environmental constraints we're going to have to expose them to.
Hi, I'm Nate Hefty, Vice President of Sales at Superior Fresh, the nation's largest aquaponic farm located in central Wisconsin. Thank you for listening to Todd-versations and Todd Bits. Check us out at www.superiorfresh.com to learn how we raise our Atlantic salmon on a non-GMO organic diet. And they thrive in water naturally filtered by our USDA certified organic leafy greens, never treated with hormones, antibiotics, or pesticides, and packed with 2 times the omega-3s. This is salmon as it should be. Shop with us online and use the discount code TLC 2022 to receive free shipping on all of our American Heart Association's Heart Health Checked Atlantic salmon. At Superior Fresh, we are changing how food is grown to change the world. Remember the code TLC 2022 to get free shipping.
I love it. Thank you for that. Something that I think, if there's a word that I could just throw out right now that I think, is probably NASA based, that's now into the aerospace. I mean, it's the word redundancy, and, how important that having that mindset in, and, to your point, you're going 3 years up, you hang out for a little while, you got 3 years coming back, what happens if there's a crop failure, right? What happens if some of these things start to happen? So the amount of thought process that's got to go into this, when I think about, I'm a big believer in the positive cost of food, and technology like this, in my mind, is absolutely a positive cost of food, because the forefront and where you guys are heading, who knows what that's going to mean for this planet as a whole as that technology comes back here. It's really interesting to me. But the redundancy, being sure that everything's copacetic back and forth, because let's face it, Elon's not putting up an In-N-Out up there somewhere yet. I mean, he might someday, I don't know, but it ain't there yet. But nonetheless, it's like, that's got to be something that you guys have to, I think it's always got to be in the back of your mind in some ways as you're developing this, I would think. Was it not?
Yeah, I mean, I've actually given a couple of presentations just to explain how the engineering philosophy changes when I start talking about a long duration mission where there's no chance of resupply. Right now on the International Space Station, if you have a system fail, you basically send up another system to replace it, system component. I think the longest we've been between missions to the International Space Station has been like 118 days since assembly was complete.
119.
Something short. All right, 119. And, when I look at a mission to Mars, it's like 700 plus days potentially we're working to.
Right.
So I have to deal with several things. First of all, there's the communication aspect. You have these time delays that can be up to 45 minutes for a round trip communication. That makes it very hard for the traditional role of ground stations and ground experts directing the crew how to perform certain tasks. That really becomes more challenged in this environment. The crew now has to be able to do these tasks. And that brings in a whole other series of expertise and technology that I'm not an expert in by any means. But there's going to be a shift there in terms of approach. That the crew is going to have to be the first line of defense, in terms of repairing and maintaining systems. I've often thought that while astronauts have been trained to do specific tasks and they're trained on the different experiments they're going to work, realistically, when you actually are conducting operations, the ground does a lot of the direction alongside the astronauts. They're there as a helping set of hands and guidance, and with experts, they can rely on the ground to help them through as well. You're not necessarily going to have that flexibility to the same extent on exploration missions, as depending on how far people are away. So that becomes a challenge. Then the other thing is, if you're going to do maintenance now, instead of having a system that's failed and you change out basically a larger subset or components of that system, you're not going to have the ability to do that, because you are only going to have with you what you took when you left. So, when I talk about a mission to Mars, it's not just the vehicle, the crew, the food, it's the logistical supplies that are needed to maintain the systems that are on board. So being able to reduce the failures is key. NASA has gone a long way with the International Space Station to understand how to design different systems to become more robust and more reliable. We could never have avoided space station and made the mission directly to Mars. We would never have had the mass budget to be able to do that without the experience that we've gained. So when I talk about spares, I really need to get those number of components down to an absolute minimum. And then I have to be able to design the hardware such that they're easy to repair. So that's a challenge in and of itself. In the past, it didn't really matter where this widget was inside a subsystem that would have failed, because I've just replaced the whole subsystem. Now I have to go in there and get directly to that widget and have crew or a robot or a robot aid help in doing that. So we have to design the system such that the components more likely to fail are easier to access, right?
I love it.
And then there's a whole lot of other things that have to get taken into account that are different when I'm talking about a long duration exploration mission. One of the things from a plant perspective, my ultimate goal is the systems we bring forward are like a robotic farmer. So that means that not so much the word robot can kind of be misused. It's more or less a smart farming system where by my sensors on board, I can get early detection when I see issues going on with plants. And I think, hyperspectral imaging, multispectral imaging gives you early insight before the human eye can detect it, because I have to make sure I can protect every crop grow out that's going on, just because of how important that is. So when I can take an advanced imaging system like that, along with other sensors that are, typical to CEA, and build a case where now I can have a smart system that can collect all this data, evaluate if I have a sensor failure or if there's really something going wrong with the plants, basically, identify the problem based on having been trained by a large series of training set of data before they were ever developed and launched, and then, figure out what the problem is and remediate it, and then notify the crew that, hey, there was this situation and we're addressing it, or if there needs to be crew interaction. That minimizes the amount of expertise and attention the crew may ultimately have to play on some of these systems. So we're trying to do everything we can to make a system as potentially automated as possible, from seeding all the way up to harvest and cleanup, recognizing that the crew is going to want to get involved in some of these activities. I mean, there's a big psychosocial benefit for being exposed to the plants. We don't ever want to prevent the crew from being able to do that kind of work, but we also want to take some of the burden off of them for times and periods where they're just so busy with other tasks, or to do things that the crew doesn't have any interest or any real desire to do.
Right.
So trying to make a system that'll eventually be able to do all of that.
Well, yeah, thank you. You touched a little bit about being a part and seeing some of these startups and going. And I just want to come back to that really quick and just throw this question at you. Because there's so many now, because, I flippantly said they're almost, they're CEA startups are almost like Starbucks. They're on every street corner, it seems like now. But because there's so much energy going to this, and on a global scale, right? Not here in the States, but on a global scale. Are you being taught anything by some of these startups? And you don't have to share what it is and don't have to give any names. I don't put you on the spot, but my question really comes from, because there's so much energy into this now, is it helping propel what you guys are doing now at NASA?
Yeah, I think one of the challenges for me personally, I think I can speak for most of our group, is that there's so many companies out and doing this kind of, investing in this new technology, and whichever aspect of it is that they is what they call their primary area, and there's so few of us that it's hard for us to keep track of all of these folks.
Right.
Some of the work is is more like the Wizard of Oz, that if you look behind the curtain, there's not much there. There's a lot of that. There's a lot of international work that we really don't have maybe I would say the ready access to see exactly what they're doing. And then there are folks out there doing things that are real important. So that's where we have a series of, programs like the SBIR, STTR program, where we can go out and say, hey, we are working in this area and we need help in this field, and then put out a solicitation that people can go and look and find out about and then respond to, and then there can be down selects based on that. And we can work with these companies. We see who's doing what in the field. We see where the expertise is. There's the option to go forward with, depending on how far this SBIRs are taken, to eventually even making some system that would eventually potentially fly in some capacity. So
I love it.
Yeah, it's very much a matter of trying to really understand the lay of the land. And I think that's where we're challenged, is that there's so much going on, whether it's in technologies on the hardware side or plant technology, that it's, and there's limited funding in what we do, that we really have to, one of the biggest challenges I have is having people come out and contact us, and very motivated and interested. The typical example is you have some CEA company who's doing really good work. They're very concerned morally and ethically about feeding the Earth's population as best they can, coming up with new technologies to make food more affordable, to put the source of production of food closer to the communities that would benefit from it, doing all this stuff. And then there's an aspect of usually they're younger, energetic people who are working on these companies. They would love to partner with NASA in some way, shape, or form. And you have this energy, and people super excited will come and we'll talk with them. But then there's a limit to what we can do based on the funding we have,
Right.
And so that becomes frustrating for me. It's almost like when someone reaches out to me, there's periods of time where we're so busy with certain things that, I will always go and talk with them, but I really can't do anything for them in the near term because, our budget cycles just don't work that way, where I have, extra funding sitting in the bank that I can apply to an interesting idea or topic.
Topic. Well, and thank you for that. It's just interesting. I think people listening out there in the space, I think their ears are going to perk up a little bit and go, what? Wait, what? How? Where? Well, I'm going to the website, because I'm sure they all want to learn. I mean, look, and to your point of funding, let's be realistic. I mean, this conversation is really about the future of food in a whole lot of ways, not only for getting out into space and wherever that takes us, wherever we build our next condominium community out there, whatever it might be, but it has a lot of positive ramifications for this planet right now. Yeah. And I think that's something we've got to lead into. So when I think about funding NASA and food, going back to what you create, hey, I grew up with Tang, I know what it is, right? But going back to that, I think it's important that we recognize the value that the work that you all are doing is really about the future of this planet as much as it is, a crew going to Mars.
Yeah, I find it real interesting because I really appreciate all the work that the folks in the CEA world are doing. And from my perspective, even the Deep Space Food Challenge is a lot about how do I feed people on Earth. We started this as a NASA challenge, but the Canadian Space Agency wanted to get on board, and they were looking at it basically as a way to come up with ideas and concepts. How can I feed local indigenous populations in the north of Canada that don't have access to quality nutrition because they don't have an environment that can grow it?
Right.
And then that plays into climate change, and how do I now, instead of trying to have countries going out and purchasing land that, land in their country used to be able to grow a certain crop, but the climate's changed. Now the place that can do that is some other country. We got to buy lands there so we can ship produce over. How do you break that chain by being able to come up with CEA deployable systems that you can put near certain communities or people to get access to food? And whether that's in, because there's been some kind of environmental disaster, hurricanes, drought, whatever. And when you talk about systems like that, if you envision something on the order of a freight farm or something like that nature that can be deployed, that's not going to be too far off the model that early lunar systems would most likely be, and so it's something that we work closely with. We actually have a researcher who she's just, I think, coming up on the end of her stint down in the Antarctic. NASA partnered with the German Space Agency, DLR. They have a greenhouse down in the Antarctic at their Neumayer facility. It's like 300 or 400 meters away from the main station, which is nothing like McMurdo in the South Pole for the U.S. It's not a series of buildings and infrastructure. They have one station there, and they basically deployed this freight container sized greenhouse. And we've had one of our researchers operate it for the past year, and she was down there overwintering with 8 other people. So there was a crew of 9. She was the one responsible for the greenhouse, and she's been down there over a year now. Most of that time was during an Antarctic winter. And so I sit there and look and I say, who has ever had better experience in terms of isolation for a long period of time in a hazardous environment, working with plants, even though it was, on the Earth, and keeping and maintaining and running a plant system. This lady has got more experience, and I'm sure she's going to be well sought for after she gets back. The year of her time will have been well worth it. And there's a lot we're going to learn.
Right, and that's Eden, right? Eden ISS, is that what you're referencing?
Right.
Yeah, which is really interesting. Right. I mean, and to kind of sum that up for everybody, what Eden is, to your point, it's a research facility, but it's really about working to advance CEA agriculture. And you want to go to a harsh place. You want to go to Mars, go to Antarctica and hang out in the middle of the winter.
I think that another thing about this, Todd, that illustrates the point is that, whether it's with the Deep Space Food Challenge or whether it's with Eden ISS, this is really an international thing. I think that we do our best when we collaborate internationally. Something like a crop production system on a space mission, it's always more challenging to sell if there's only one space program backing it. So getting an international consortium together, interest. The folks with DLR are very much into designing space systems that can be put on the moon. Our focus has been more in terms of primary research on growing plants and some of the subsystem technologies you would use. The Canadians are also interested in this. So I think there's really a good potential to forge an international collaboration, because the way I look at it, when I finally deploy some type of plant growth system on the surface of the moon, unless it's something that's going to be out there decades in the future,
right?
Because our mission timelines won't require it necessarily till then, it's going to be either a conglomeration of international partners and or a commercial endeavor where someone says, I want to do this, and I know it's going to cost me money. There's not going to be a direct, payback from this thing itself initially, but it's going to be a way for me to get our company's name out there or get our group's name out there and help maybe do things on Earth. So I don't know. I'm not a business guy in that mindset, but my hope is, and my expectation is, that when the first plant production system on the moon is deployed, it's not going to be something we've made in-house. It's going to be a commercial enterprise that maybe NASA writes requirements for, so that it meets our design. But and again, that's a lot of my speculation based on just being in the field.
Yeah, but going back earlier to what we just talked about working to the food supply here on this planet, I think we need to be mindful of the importance of the work, because if you take a look at what the UN saying, what do we got? 2.3 billion more people coming on this planet by 2050. I mean, in dog years, that's like tomorrow. So
what I say in my presentations is that usually this is to a CEA audience that these folks are trying to feed 10 billion people by the year 2050, and I'm looking to feed a crew of 4 to 6, but I'm going a different place.
You're definitely in a different neighborhood.
But in my mind, they have the really important task. We'll hopefully piggyback off that to some extent, and hopefully move it into the future faster as well with some of our research.
Absolutely. Another big pie in the sky, floating up there with the space station question. At this point, we know that there's not really a food system yet that's ready to kind of meet this long-term space stuff. And we're getting there, right? It's a part of the process you're doing. Again, pie in the sky, big question to ask. When do you see it as kind of being feasible and coming to fruition that you're going to be comfortable saying, hey, we did this, we feel good about it? I mean, do you think it's a 5-year process, an 8-year process, 10-year process?
Yeah.
It's a hard question to ask because there's so many variables, I would imagine.
It's a hard question because a lot of what it takes to answer that question is predicated on our access to this deep space environment to be able to conduct some of the research that has to be done. We're not the only people looking to get space on missions that are going beyond LEO. So we're in competition with others. So how we write and craft proposals, how we approach funding sources and getting their backing goes a long way into the number and timing of our opportunities. And that is in addition to just the fact that a lot of these things are going to take time to work out. What I look at a crewed mission to Mars sometime, late 2030s, very late 2030s, more like early to mid 2040s. That's a lot later than a lot of the wonderful YouTube videos by people put out there that say we're going to have colonies on Venus and in the atmosphere of Venus by 2050. So I look at those and I shake my head because the realistic timeline is much more in line with what I just said. And so I'm going to need to have my goal is to have a system on a transit mission to Mars in that timeline. So late 2030s, early 2040s.
Right.
Now, the infrastructure plans are such that the transit vehicle that's going to take us to Mars is going to go to cislunar space and reside there for a significant period of time before it actually makes the crew journey to Mars. And that'll be in part to outfit it and in part to do shakedown cruises of a similar duration, is whatever the program decides on, but it'll be a longer period of time. And so that means I would have to back up, and I would love to have my system has got to be ready to be on that vehicle at some point. So that moves me up into the 30s time frame, which isn't that far away when it's 2022. And usually I assign about 5 years for kicking off a project like this to having hardware delivered. So realistically, we're pushing now. I think the requirements for a Mars transit vehicle, the first level round of requirements is going to be coming up in the next year or two. So even though, my first date seems so far out there, we have to start work, now with some urgency, or we have to figure out when can I get incorporated on a system like that. Right. And again, I still need to have the powers that be, the people who are working and designing both the vehicles, the architecture and the mission design, saying, yeah, we can accommodate a crop system here. But I have to be ready in case they do. And the hope is and the expectation is that they will. But, this is, working within the government, we're straddled with continuing resolutions. We're operating this fiscal year at the same funding level as we were in FY21. So any of the work that we had proposed to do this year that might have incurred more original, costs associated with it has to be throttled down to a level of FY21. So it's a challenge. And that's why, whether it's us working within NASA or CEA companies who want to partner with NASA, they have to be in it for the long haul. This is not something that's going to happen overnight, and it's something that's going to require patience and consistency and and perseverance. Well,
look, to your point about getting up and colonizing someplace, like it's probably the easiest thing is to probably create something that's going to fly from point A to point B. It's everything that's in between point A and point B is the problem, right? I mean, I'm not trying to downplay anything, the big work that all these, the folks are doing, but, getting there is probably, just plain simple with the vehicle is not that difficult in the scope of things, right?
Yeah, the vehicle work, I mean, it's challenging, but it's in the nature of challenges that we've been dealing with, since
for 40 years,
since the end of the Second World War.
Right.
It's how is the crew affected? What new factors is going to affect the crew? You read almost every day about potential crew safety concerns and health concerns for being exposed to this environment for so long. And, I think there's a lack of appreciation as to how far away Mars actually is and how that requires a whole paradigm shift in how we develop and design and manufacture hardware. It's not an easy set of challenges to work with at all. And I'm just really, what I can say is that from my little snapshot within the agency, the people working on all these things are brilliant people. They care about this with a passion that's unrivaled. And, and that's the kind of thing that's going to help us get through this and get us there is dedication of the folks within the agency, also within some of the commercial companies that are really committed to spaceflight and to seeing humanity become a more than one planet, species.
Absolutely. You said something I have to go back to it. I wrote it down. I don't want to forget it. You talked about taking Chips Ahoy up there, but why are crumbs a big? So I got to ask a question about crumbs in space, though. I can't let you go without it. Tell me a little bit, just briefly. Tell me why that's a problem up there.
Well, you've got them floating around, and they go into the filtration systems, and they clog, filters and things like that. So yeah, that's all. The food that we bring has to take all that into account. Yeah.
Right. I love it. Well, thank you. I want to shift gears real quick. I want to have some fun because, you're doing some amazing thing. You're incredibly inspirational to hang out with. And I've enjoyed this tremendously. And I think people are going to be blown away by this. But I got to ask you a little bit. We'll play a little quick TLC trivia. Put you in the hot spot real fast. It's easy. You can do this. So let me ask this question. What is a May Queen, a Wishley crab, a fox whelp, or a Lane Prince Albert are a species of what?
A crab. I don't know.
An apple. An apple.
An apple.
An apple. All right, here's another one for you. Who was the
my
legend?
Scientist friends are hitting me in the back of the head.
I know. That's why I threw that one out there just to get. I got more for you. I threw that one out there. I knew it was going to get you in trouble. So, who is the legendary monk that invented champagne?
I have no idea.
Dom Perignon.
Oh, really? He was a monk?
He was a monk. I read the trivia. I don't write the trivia.
If you ask me World War II trivia questions, I'd be all over it. But.
Well, I don't have. I don't have. I'm not going to lie to you. Here's another one for you. Which animal is responsible for killing more people than airplane crashes?
This could be. Let's see. Hippo.
Donkeys.
No, that wouldn't be enough.
Donkeys.
I was going to say like a horse.
All right, well, here's one.
How far does that go back? Is that per year, or is that per
I got to be honest with you. I found the trivia question and thought it was hilarious and thought I'm going to ask you this question, and I did not do the deep dive. But I will get on the Google machine and I will dive into donkey trivia deeper. I will email you the answer. So here's one. I want to know who came
up with that. Go ahead.
Here's one for you: Star Trek or Star Wars?
Oh. I'll tell you, it was probably Star Trek for me because I was a kid then, and I was impressionable about it, and that set the bar.
You think that helped? Do you think did that kind of inspire you a little bit? You think?
I look back on my life, and it's very interesting in the sense that at no point did I ever think I would be working for the space program, but these vignettes of memory come back to me. When I was a kid, I was in my parents' house, and this was back the night of the Apollo fire, when Chaffee Grissom and what was the first walker in space? I can't believe it. Ed White were killed, and at that very time, I was doing one of these. It was a Venus pencil by number. They would be pictures that they had broken out. You'd cut different colors, and you'd fill. Right. And I was doing a spacewalk when I heard when the news came over the TV that he had been killed. So that's like one of my first memories that I can put towards space. And I was always interested in working more or less in astronomy and astrophysics, but my family moved to the east coast of Florida, and it became a natural to, go to school for that here locally. And then when you graduated, the pathway was to go and get a job at the Space Center. So I never really anticipated that, but I can think of a lot of space things that happened in my life that kind of said it was kind of like a stream pulling me this way that I didn't even realize was flowing with that current.
I love it. Hold on, I got some. I got to grab some. Hold on, I got one more final question. I got
not a trivia question. Is this
no. This is my tinfoil hat for the next question. So I'm gonna put my tinfoil hat on really quick and ask you this question. Science. Are there aliens, and are they cool?
As a NASA employee, I don't think I'm allowed to really comment on that. But I would say that space can be cold or hot, so it's hard to tell.
You know what? I'm going to take that answer. I'm going to take that answer. That's perfect. I'm perfectly fine with that answer. Absolutely fine with that answer. I'm going to go with that's kind of a soft yes. I really appreciate you hanging out and having some fun and sharing with us with what you do. And normally on my broadcast, I always have a final question I throw at people. But today I thought I'd do something different, maybe make a little final statement and just say how important the work is that you all are doing. Not only about the future of food on our planet, but who knows what's out there? Who knows what benefit we're going to get by putting energy going elsewhere? And I'm not necessarily so sold on building condos someplace, but I'm more sold about what's up there, what's out there, what can we learn, what part of the galactic history out there that can we benefit from by the hard work that you're doing. But something that you said that impacted me and I wanted to bring back around to close out our time together is how important the food is in space and how important the experience of food is and how much that when you're away from home for 3 years and, you're missing a birthday or, the first basketball shot or whatever the case may be for these guys and gals that are up there serving our country and serving a bigger cause, how important the work is that you do, because that is a piece of home and that is a piece of community that they share together. You go online, you look at the pictures up at ISIS, those guys are sitting around a common table, having a meal together, even though they live side by side, never get away from each other type of a deal. Right. But I mean, nonetheless, that the community that comes out of the food experience is so important. It's so marked in the tradition of our country from Thanksgiving to Christmas to birthdays, whatever the case may be. And I guess where I'm coming around to is saying thank you for the hard work and thank you for what you do. And thank you, and let's find you guys more money because I think it's well worth the spend, right, to see where this goes. And that, I just wanted to say how much I appreciate what you guys do and what the difference you're making on this planet, what the difference you're making to the food system, and to know that there's people out there that appreciate it. There's people out there that want to lift your message. And on those days you get a little discouraged, just know you got somebody out here like me that's willing to go kick some clods for you and getting a little scruff to keep the ball moving down the field. So that's not really a question, more of a final statement, but I just wanted to give you a proper thank you.
Thank you very much, Todd. It's well appreciated. I mean, I think you get it. There's people out there who don't necessarily get it all the time, but yeah, if you look at the history of exploration, food has been tied to it from the very beginning, as you said at the beginning of the broadcast, and it's going to be that way, as long as people are around. And our job is to make that aspect of the travel as positive as possible, and to take some of that knowledge and bring it back here on Earth and help take care of some of the challenges we'll be facing as a community, a world community in the future.
I love it. Ralph, thank you very much for hanging out with me. I really do appreciate you taking the time. This has been so much fun, and I've enjoyed this conversation, but I've also enjoyed the amount of research I did prior to this, because it's fun for me. I love the topic. I think it's really cool. I see the big picture. I love it. And to be able to spend some time hanging out with you has been very, 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 very special to me. So thanks again for your time.
Thank you, Todd. Appreciate your interest and your time.
Thank you. Everybody, thanks very much for hanging out with us. Remember, I say it all the time, go inspire somebody. This talk inspired me, and hopefully it inspires you to get a little more involved. Maybe go online, find out where the space station is. Get your kids to go look up with you. Go check it out. I'm telling you, it's very cool. There's a lot of cool things to see. Go Google SpaceLink and go see a satellite train. There's all kinds of ways to go look up and see things. Looking up is a good thing, and it could be a source of inspiration. So thanks for hanging out with us. We'll see you soon. Don't forget to check us out on social media, and we'll see you back with another Todd-versation, another Todd bit, whatever's next. We got a good, exciting second season ahead. Thanks, everyone, for being here. Take care. Bye-bye.